thing you want to do is figure out what type of solid you're looking at. So it's a pyramid. The base is a regular hexagon. Okay, so if I kind of sketch that, here's my base. And then if I connect those to a point, so this would be sort of a rough sketch of this. You don't specifically have to draw this in. You can just use individual parts. But if I then look at my base is a regular hexagon, and when I draw my reference triangle for the regular hexagon, it winds up being equilateral. So that is unique to the regular hexagon. So if I know that the height of this pyramid is 18, and the apothem measure here is 2√3, and that's the only piece of information that I have. Okay? But my surface area calculation is going to be one base, which is 1/2 SAN, plus, because my base is a regular polygon, I can use the formula 1/2 PL. So I need to find what the length of my side is, this whole length here. Well, when I create this right triangle here, it is a 30, 60, 90 triangle. So looking at this 30, 60, 90, the side opposite 60 degrees is 2√3. That means the side opposite 30 degrees is going to be 2, giving me the whole length of the side of 4. So I know my side length is 4. My A value is 2√3. My N value is 6 sides. Okay, plus 1/2 the perimeter of my base, because it's a regular polygon. It's 6 sides that are each 4. So 6 times 4 is my perimeter. And so the last thing I need to do is I need to find my slant height. Okay, so finding the slant height is this measure right here. It's the height of this, the triangular lateral face. Okay, what I'm going to do is I'm just going to kind of take a side view, and I'm just going to take this whole triangular side, and I'm going to move it down here. Still at a perspective, so I can kind of see it's at a different angle here, actually. I'll put it at the similar type of perspective. So this is my triangle just written or drawn out and independent. Okay, so the L value, my slant height, is going to be the height of that right triangle. Okay, well, in order for me to find that, what I'm going to have to do, so here's my slant height right here. I take the fact that my height goes from the vertex to the center of my base. So this whole measure here is 18. So I can draw that straight down here. 18. And then from this point to this edge again, we'll form a right triangle. So this is a right angle here, where my slant height is the hypotenuse of this, and this distance here is an apothem. Again, the distance from the center perpendicular to any of the sides is the same, and it's going to be 2√3. Okay, so knowing that, it allows me now to find my L value, my slant height, because it's a Pythagorean theorem. Hypotenuse squared is equal to the sum of the squares of the two legs. And so if I calculate this, 18 squared is 324. 2 squared is 4, √3 squared is 3, 4 times 3 is 12. And so if I combine those, I get 336 is equal to L squared. Extract my square root, and I get L. My L value here is equal to the square root of 336. Okay, so I now have my my entire surface area ready to be calculated, and so it's just a matter of plugging that in. 0.5 times 4 times 2√3 times 6, and to that I'm going to add 0.5 times 4 times, or 6 times 4 is 24, times the square root of 336. I'll close that off. I've already entered decimals, so I'm good there. When I hit enter, I get my total surface area of 261.53 approximately. And the units here are centimeters to the second degree.